Hello again. So we have reached exercise 20, which is about to insert an element into a sorted array. So we have an array of dimension n plus 1, and we have in it just an element, and we need to insert an element into this array, which is sorted, and we want to keep it sorted. So we have, for example, this array. So we have so of size n plus 1. However, it contains just an element, and there's one cell empty. This is here. So and for example, let's say we want to add 15. So 15 should come in between 10 and 30. So I should start from the end, move 30 to the last position, and then 20 to the place of 30. Now I have 10. 10 is less than 15, so I can place 15 here. So I'll be using the functions that we've already wrote. So the reading of dimension, the reading of the array, and the display. So I will suppose here that for the reading of the array, the elements should be read in ascending order. So you can check the solution of the array, the previous exercises, in order to do a do while here. For example, we need to read first the first element t of 0, and then do a loop from 1 to n, and do a do while here. So we already worked that, so I will not spend my time here. However, I will work on the insertion of the element. So the insert, so either we can return the newest dimension, or we can know from the beginning that here the dimension is so it's plus 1. So let's say that I will reserve t1, which is size plus 1, because in the reading dimension the maximum dimension could be of size. So if the user enters 100 element, I have reserved 101 element, because later on I will insert an element into this array. So let us first print display the array, and then do the insertion. So here we have t1 s1, and then I will insert the element. So the insertion would always succeed. So I can either say that in t1 I will add the element x here, so of dimension s1. So I can return the newest dimension, which is equal to s1 plus 1. So I can write s2 if you want. Otherwise, you can keep it as this, because we know that s2 is equal to s1 plus 1. So you can omit this if you want your function to return void, to return nothing. So I will keep it like this. And then, of course, so I need to read x. So printf, enter the value, enter x, and then I need to scanf, and that's it, and I will reprint the array one more time. So however, here I will display t1 of size s2, or I can write s1 plus 1. So let's do the insertion. So in my prototype, it will return the newest size. So it's an integer here. I have insert. It takes an element to be added. Then the array. So let's call it t. And then we have the size. Let's call it n. So how can we do? So we need to start from the end, from s1. So from the n here. And then we do the moving of the element. So we move the element until we can reach an element that is less than the element which is I want to add, which is x, and then I will add the element and everything will stop. So we need a counter. So we will start from the end. So for I equal to n, so why it's let me tell you. So it's I equal to n because in t of I, so in t of n, I will place ti minus 1. So as long as ti minus 1 is greater than x, that the one I add, so the negation of these is whenever x is less or equal, and I will do I minus minus, and in ti I would place ti minus 1. So this is what we have already told you, and in ti, whenever I'm out of the loop, I will place my element x, and then I will return just n plus 1. So let us just run this program and see what is the output. So let's say I have the dimension equal to 3. I will add the element 10, 20, and 30, and then I will add 15. So I will end with 10, 15, 20, and 30. So let's take the limit cases. So let's say I have dimension 3, 10, 20, and 30. And let's say I will enter 40. So it will work. So let's enter 0 now for x. So there's a problem here. So why there's a problem here? Because I am looping from I equal to n to ti minus 1 less than xi minus minus. So whenever I'm reaching the 10 here, so which is at index 0, so I'm copying ti minus 1 into ti. So what does it mean ti minus 1? It means that the element that it's before 10, so it's a random number. I don't know what's in the memory. And then I'm placing in ti. So look well, ti, there's no condition on ti. So there's a problem here. So why there's a problem here? Because I'm placing a 0 somewhere far from I. So the problem comes from here, because even when I reach I is equal to 0, I'm looking for minus 1. So in order to do that, I should be sure that I is always greater than 0. So if I is greater than 0, I can ask myself if t of I minus 1 is greater than x. For example, if I equal to 1, I can ask t of 0 if greater than x. But if I is already equal to 0, I cannot ask if t minus 1 is equal to x. So let's rerun this and check if it will work or not. So 3, 10, 20, and 30, and let's add 0, and yes, now it will work. Because if you didn't get the idea, just try to make the memory state of this function whenever we have when we omit this condition, and you will see that we will be out of bound in this array. So this is the solution for this question. So if you want, you can write it recursively. I will not write it recursively because it's a bit difficult, and you will write it the next year. So, and this is it for this exercise. If you have any questions, do not hesitate to write to me, and of course I will answer you back. And again, thanks for watching.